Now, the fourth subtopic on differential calculus is differentiation from first principle. This is where we are going to start, we are going to start real work on calculus. Let us check this. Find the derivative of a now find the derivative of a. Y is equal to x square, y is x raised over cube, y equal to 1 over s, y equal to 4. This thing is very simple, as I said. It just requires concentration. Now, the a, we have y equal to x square. The y, the s, is what? This will be, the coefficient of this s square is 1. That's 2 times 1, 2. S, here 2 minus what? 1. This will become 2s. The y ds of s square is 2s. B, we have y equal to s cube. The y ds is 3 times s, 3s. This will be 3 minus 1. That's 3s raised to power 2. As the y ds of s cube is 3s squared. The c, we are having y equal to 1 over s. There is no way we can derivate this. What are you going to do? Remember, when we have 1 over a, it can be written as a raised to power minus 1. To eliminate this in indices, this will become 1 over a. Is it not equivalent to this? Therefore, y can be written as s raised to power minus 1. We can then derivate now. The y ds is minus 1s, or you can write minus s raised to power minus 1 minus 1. This will become minus s raised to power minus 2. Therefore, minus 1 times 1 over s square. To eliminate this minus, this will become minus 1 over s square. Therefore, derivative of the y Derivative of 1 over s is what? Minus 1 all over s squared. Now, the last one, which is y equal to 4. When you are asked to derivate this kind of constant, 4, y equal to 4, the y ds of this equal to 0. I will not talk much on that. The y ds is equal to 0. Let us look at some different set of examples on differentiation of first principle. I hope you have understood the concept of derivative now. Let us check these examples. We are still on differentiation of first under the first principle. Now, find the derivative of the following. They are very simple. What are we going to do? Solution. A is y equal to s7. What are we going to do here is the y ds equal to 7s 7 minus 1. This will be 7s raised to power 6. The y ds of s raised to power 7 is 7s raised to power 6. B, y equal to s. The same thing, what we apply here is going to be applied here. This will be the y ds equal to half s half minus 1. Remember, this will become 1 all over 2 times s raised to power minus half. This will become 1 all over 2 times 1 all over s half. This will become 1 all over 2 root s. Do you know how this one become root s? When you have s, when we have s raised to power half in indices, this is s will become, this 2 here will become here, this one will become here, 1 will become here. That's why 2 means square root. But if the question is like this, 1 all over 3, this s will be here, 3 will be here, this is cube root. If it is s raised to power 1 all over 4, it will be s fourth root. Whatever at the top, it may be 1 or 2 or 3 will be outside like this. But for here, it will be, for this one, it will be 1. That's how we got this one. 1 all over 2 root s. The last, the C question is, let me do it at the other side. C, y equal to 1 all over s cube. There is no way we can differentiate this. What are we going to do? We cannot differentiate like this. We say, are we going to say product or what? What we are going to do is to reduce this. You know, as this one is now, this is, if we say s raised to power minus 3 now, see, to eliminate this minus, it will become 1 all over s. Can you see? That is why we need indices. The law of indices is very, very important in calculus, because there are some questions you need to take back to the former position it was before they put it into calculus. Now here, our y will be s raised to power minus 3. We can now derivate the thing now. The y, the s. The y, I told you, the y ds means derivative of y in respect to what? S. That's meaning of the y ds. Mean derivative of y in respect to what? S. Therefore, the y ds of s raised to power minus 3, it become minus 3s raised to power 3 minus 1. This will become minus 3 s raised to power minus 4. You may not leave it like this because we still have negative at the top. This will become minus 3 times 1 all over what? S4. This will be minus 3 all over S4. This is our final answer. We still have question, that is D. That one is y equal to cube root of S square. This 3 here mean cube root. How do we do this? This is very simple. You see, I have told you the knowledge of, if you don't know indices, it is better to tell me, make I teach you indices. Here we are going to apply indices rule. This is y equal to, this one means s raised to power 2 here times what? 1 all over 3. This 3 means 1 all over 3. Before it can become this, it was 1 all over 3 before. This will become y equal to s raised to power what? S raised to power 2 all over 3. From here, we can then differentiate now. How do we derivate this? This will become the y ds equal to, this will be 2 all over 3s, 2 all over 3 minus 1. This mathematics is very simple. The y ds will become 2s all over 3 raised to power what? 2 all over 3 minus 1. How do we do that? 2 all over 3 minus 1, LCM, 3. 1 times 2, 2 minus 1 in 3, 1. 1 times 3, 3. It means 2 minus what? 3. That is minus 1 all over what? 3. Here, we can write it like this. 2 all over 3 times x raised to power minus 1 all over what? 3. As we can see, when we find the LCM, this is 12 over 3 minus 1. 3 here, 1 times 2, 2. Minus 1 in 3, 3. 3 times 1. 1 minus 3 is minus 1. This will become 12 over 3 times 1 all over s what? 1 over 3. Therefore, we can say 2 times 1, 2 all over 3 cube root of what? S. This is our final answer. I will give you some questions on the what? On the differentiation from the what? First principle. I will give you some, maybe 4 or 5 questions. So you will solve it and let me see how perfect you. The answer is 2 all over 3 cube root of s. Now let me give you classwork. I want you to work some question on this first principle. Number 2. Try these questions and let me know the answer at the comment section. Please subscribe, like, and share my content. Thank you very much. God bless you.